Since the space age began in the mid-20th century, our uncrewed probes have crisscrossed the solar system and gifted us breathtaking images of planets and moons. That's how we discovered ice volcanoes, subsurface oceans, and mountains taller than anything on Earth. Now, with concrete plans to send humans to Mars and who knows, not long after to Jupiter's Galilean moons, it feels like we're ready for the next leap. Even so, as exciting as it is to colonize our cosmic backyard, the truth is harsh. Beyond Mars, there are only a handful of moons with even minimally acceptable conditions for a lasting human presence. If we want to find truly habitable worlds, our search will have to push beyond the edge of the solar system. And that's where the big challenge lies. The distance to other planets and moons is already huge, but none of it compares to the gulf between the stars. In cosmic terms, it's like swapping neighborhoods for the other side of the world, multiplied by trillions. To reach neighboring star systems within a human lifetime, we'll have to reinvent space propulsion. People talk about nuclear fusion, laser-push solar sails, and even bolder ideas that barely fit on paper. It may sound like science fiction today, but innovation is what we do when we aim far. And when that capability arrives, the inevitable question comes up: what will be the first destination? The natural candidate is the star closest to our sun. If we look to the constellation Centaurus in the southern sky, we'll find the star system nearest to Earth. Technically, it isn't a lone star, but a traveling trio, the Alpha Centauri system. In it, the two main stars form a binary, Alpha Centauri A and Alpha Centauri B. And a little farther out sits Proxima Centauri, the outer companion, almost certainly gravitationally bound to the pair. That's why when we talk about the stellar neighborhood, we're talking about three suns that share the same home. The proximity, however, is deceptive. Even right next door, they are far farther away than our intuition allows. The fastest probe we've ever built would need more than 50,000 years to get there. Light itself, the universal speed limit, takes over 4 years to cross the gap. Proxima Centauri is about 4.2 light-years away. Alpha Centauri A and B are around 4.32 and 4.37 light-years. In kilometers, it's a number with so many zeros it loses practical meaning. Even so, if we master a new generation of propulsion, fusion, light sails, or some disruptive technology we haven't invented yet, it's plausible to imagine a journey within a human lifetime. So, what awaits us? We'd reach Proxima Centauri first. It's a red dwarf, a small, cool star on the stellar scale. It has only about 12% of our sun's mass and a radius around 15% of the sun's. Even so, it hosts a confirmed planet, Proxima Centauri B, the closest exoplanet to us. It's roughly Earth-sized and completes an orbit around the star in about 11 Earth days. Its orbital radius is about 0.05 astronomical units, just 5% of the average Earth-Sun distance. That sounds dangerously close, but because Proxima is smaller and much cooler, the planet falls right in the habitable zone. The band where, in principle, liquid water could exist on the surface. Density clues suggest that Proxima b is rocky, a solid world with surfaces, mountains, and valleys that at first glance might feel familiar. That detail alone already makes it an irresistible target. It's plausible it will be the first place outside our system where a human leaves footprints, but real habitability will depend on crucial factors. One is rotation. There are two likely scenarios. In the first, the planet would be in a 3-to-2 resonance with its star, similar to Mercury and the Sun, allowing a smoother distribution of heat over time. In the second, it would be tidally locked, always showing the same face to Proxima as the Moon does to Earth. In that case, we'd have one hemisphere in perpetual daylight and the other in endless night with a twilight belt between them that might perhaps offer more moderate conditions. Another decisive factor is the atmosphere. To keep it, the planet partly depends on the protection of a magnetic field. The weaker the magnetic shield, the easier it is for stellar activity to strip gases from the upper atmosphere. And red dwarfs like Proxima tend to be temperamental stars with frequent flares and outbursts. If the field is strong, it can preserve the air for ages. If it's weak, the planet may have been left bare over time. Practically speaking, a robust magnetic field raises the odds of seas, clouds, and weather. A weak one lowers that hope. It's an open question that the coming decades will help answer as telescopes and more sensitive instruments comb through every available clue. The surprises don't end there. There are signs of a second planet, Proxima Centauri c, orbiting much farther out, around 1.5 astronomical units. That's vastly more distant than Proxima b's orbit, and for such a dim star, would put Proxima c in a frigid regime if it truly exists. Confirmation still requires more data. Detecting it isn't trivial, and the current hints need reinforcement. In addition, the region around Proxima seems to host two dust belts, an inner one between roughly 1 and 4 astronomical units, and another far more distant around 30 astronomical units. Taken together, the confirmed planet, the candidate planet, and these belts point to a dynamic complex system rich in material that can tell the story of its formation. If, after studying Proxima, we keep going, it wouldn't take long in interstellar terms to reach Alpha Centauri A and B. These two stars make up a classic binary. They orbit their common center of mass in about 80 Earth years. The path is elliptical, so their separation varies, but on average they're spaced by something comparable to the distance from our Sun to the outer planets. What's most intriguing is that both are notably similar to the Sun in mass and size. That naturally fires the imagination. What if one of them has planets in the habitable zone, or perhaps a circumbinary planet orbiting both at once, like in certain works of fiction? At this point, scientific skepticism steps in. It's possible, statistically, even likely. But there isn't yet enough evidence to make a firm call. We need more observations, more precision, more time staring at this system. In the meantime, we keep refining techniques on Earth, hoping that before the end of the century, we'll manage to send an uncrewed probe there with a speed profile that makes the effort worthwhile. The goal would be simple and revolutionary: get close enough to capture direct images, characterize atmospheres, measure magnetic fields, analyze dust, and maybe even glimpse oceans and continents on distant worlds. A mission like that would answer questions that today we can only pose in the conditional. Are there rocky planets around Alpha Centauri A or B? Do any of them retain liquid water? How does the dynamics of a binary system influence orbital stability over billions of years? When the topic circles back to Proxima B, the question that refuses to go away is inevitable. Could we ever colonize it? The short answer is maybe, but it would be very hard. The main obstacle is the star itself. Proxima is a flare star prone to frequent outbursts that drive intense stellar winds, a bombardment of energetic particles that batters any nearby planet. It's estimated that the particle flux at Proxima B is about 2,000 times what Earth receives from our Sun. In biological survival terms, that's devastating. Microorganisms as we know them would struggle to thrive on the surface without a powerful natural shield, a dense atmosphere, a strong magnetic field, and even then, shelters. For us humans, outdoor life would be unworkable without protection. We'd need buried habitats, reinforced domes, radiation shielding systems, and infrastructure that would look more like a submarine base than an open city. Does that mean there's no chance of life there? Not necessarily. Science teaches us to be cautious. There could be exotic chemistry, subsurface life protected by layers of rock and ice, thermal niches in the Terminator region, the band between eternal day and eternal night where conditions are milder. But with what we know today, finding life like ours on Proxima B seems unlikely. On the other hand, arriving and not finding life opens a different path. We would be the seeders, bringing controlled ecosystems and bioengineering technologies to build an oasis on a harsh world. It's a bold dream, and it's worth remembering. Before we worry about colonies, we'll simply need to get there. Interestingly, thinking about these nearby worlds helps put our own planet in perspective. Here on Earth we live in the comfort zone, a stable star, a protective magnetic field, an atmosphere that wraps around us. On Proxima B, every sunrise would be a potential storm. On a circumbinary planet in Alpha Centauri, the cycles of light and shadow would follow different rhythms with two stars in the sky shaping the seasons in ways we're only beginning to imagine. They're fascinating realities full of technical challenges from radiation shielding to agriculture in closed environments, but also full of scientific promise. With a single probe, we can rewrite textbooks. With a single base, we can open an era. Until then, there's a lot to do. We need to confirm the existence of Proxima C, map the dust belts more clearly, model Proxima B's climate considering both resonant rotation and tidal locking, estimate the true strength of its magnetic field, and develop propulsion that makes the trip feasible. Each of those steps is a small brick in the bridge that connects our curiosity to humanity's next address in the cosmos. And of course, it isn't just about technology, it's also a civilizational project. It involves international alliances, sustained investment, and above all, imagination. In the end, the story of the Alpha Centauri system with Proxima and its rocky world with A and B dancing around their common center is a reminder of how young we still are as a spacefaring species. We've sent robotic messengers, yes, we've landed on comets, yes, we've observed exoplanet atmospheres from afar, Yes, but crossing the sea between the stars will be a different level of ambition. Perhaps someone alive today will step onto Proxima B's dark red soil, or watch two suns rise at once on a planet in Alpha Centauri. When that happens, it won't be a single isolated leap but the result of decades of asking the right questions, partial answers, and a healthy stubbornness in refusing to accept limits as final. The stellar neighborhood is right there. It's up to us to build the path.